Okay, so today we're doing 3.5 slopes of lines. So this should be a really good flashback to Algebra 1, something you hopefully are really good at and spent some time on so you're comfortable doing it and that you will actually feel like you're being successful when we do this in class. So we're going to, the essential question, how can you use the slope of a line to describe the line? So what we're going to learn is to find the slopes of line, use slope to partition directed line segments, and identify parallel and perpendicular lines. So let's get started. And the first thing is slope is. So what is slope? So slope is, and we'll type this in here, and we're going to say slope is the steepness of a line. Make that a little smaller. There we go. Slope is the steepness of a line. Slope is rise over run, or also known as the change in y over the change in x, notated as delta y over delta x, which means y2 minus y1 over x2 minus x1 for any 2 points. So as long as you got 2 points and you label them, you plug them into this lovely formula for slope. Also called rate of change, so it's a fancy way of saying rate of change. So the change in the dependent variable divided by the change in the independent variable, so change in y over change in x. Slope is units, so miles per gallon, cost per item, feet per second. And the top unit depends on the bottom unit. So dependent over independent. There are 4 types of slope. We have the positive slope where we're walking up. Then there's the negative slope, which is going down. There's a slope of 0. And when it's a slope of 0, the equation is y equals some number. And then we have the undefined slope, which the equation is x equals some number. And we will get more into that. Actually, let's go ahead and let me show y'all this little trick in case you've never heard of it. So here's your xy axis. I'm going to write the words vux hoi. It's a funny sounding word. So what happens is when you have a vertical line, so if you have a vertical line, so VER, so vertical, the slope is undefined and the equation is x equals. When you have a horizontal line, the slope is 0 and the equation is y equals. So kind of a way to remember which one goes with which. So when you have a vertical line, it's undefined and it's x equals some number. When you have a horizontal line, the equation is y equals and the slope is 0. So vux hoi. All right. Identifying and interpreting slope. So determine the slope for each of the following. So we have a vertical line. So remember you got V, U, X, and then this is your H, O, Y. Vux hoi. So we have a vertical line. So vertical means the equation is x equals. So x equals whatever number it goes through. So x equals 3. And since it's straight up and down and vux, the U, it means undefined. Okay, this one, we've got a slanted line, so we don't have to worry about it. We can just count. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we're going to rise 8. And we're going to go over. So we did rise all the way up. We're going to go 1, 2, 3, 4. And we're going to rise 8 and run 4. So rise 8, run 4. 8 divided by 4 is 2. Therefore, my slope is 2. And then over here, we're going to go rise 1, 2, 3, 4, 5, 6. Oops, nope, not 6. Just kidding. We're going to, let's make that smaller. All right. So we're going to draw our little triangle here. So we're going to go 1, 2, 3, 4, 5. So we're going to rise 5, and we're going backwards 1, 2, 3, 4, 5. Going backwards 5. Well, 5 divided by negative 5 is negative 1. So the slope of negative 1. So we have a negative slope, positive slope, and defined slope. All right. So let's determine the slope for these. Now, this time we're not on a grid, so we can't just count. So if they give you a table, choose 2 points. Choose 2 points. It doesn't matter which 2 you choose. Just choose 2. I'm going to choose this one and this one. So my formula is to use y2 minus y1 over x2 minus x1. So we'll call this x2 and we'll call this one x1. This one's y2 and this is y1. So y2 is negative 2 minus y1, which is negative 2. x2 is 3 minus 1. So 2 negatives make a positive. So negative 2 plus 2 is 0 over 2, which is 0. So my slope is 0, which means a horizontal line. All right, let's take a look at this one. So this is where I can do the whole labeling. So I've got x1, y1, x2, y2. So I'm going to plug it into the same formula. So that's 3 minus 11 over negative 1 minus negative 3. Well, 3 minus 11 is negative 8. These two negatives make a positive. Negative 1 plus 3 is 2. Negative 8 divided by 2 is negative 4. So my slope is negative 4. All right. Sketch a graph of a line that has a slope equal to 0. So I have the x and y axis. So here's x and here's y. Sketch a graph of a line that has a slope equal to 0. So all you got to do is draw a horizontal line. Slope is 0. Super easy. Super easy and some good review. All right, this one says to find the coordinates of point P along the directed line segment AB so that the ratio, remember this, ratio of AP to PB is 3 to 2. So we got a ratio of 3 to 2. So that means how many parts are there going to be? Well, 3 plus 2 is 5. So we're going to divide this into 5 parts. And it has to be 5 equal parts. So it's going to be 3 parts out of 5 parts. So point P is going to be 3 parts in. So 3 to 5. So remember, there were 3 steps, and y'all did really good on this on the checkpoint. So we need to find the length of AB. So what we're going to do is, remember, we have to do 2 parts. We have to do the horizontal and the vertical. So let's do this. Let's find the horizontal and vertical distance. So let's see. The horizontal distance, well, it's basically like taking your slope. So if you take your slope, 1, 2, 3, 4, 5, 6, 6 over 1, 2, 3. And we're just going to multiply the top part by the fraction, because that's my distance, times that. So that's 18 over 5. And then we're going to do the same thing down here. We're going to multiply it by 3/5. And that becomes 9 over 5. And then we're going to, let's just go ahead and convert this 18 over 5 into a decimal. So 18 over 5 is 3.6. 9 over 5 is 1.8. So now you take your starting point. So 3 is the starting point. So add that to here. 2 is the starting point, so we add that to here because this is your X and your Y. So remember, this is your Y's and these are your X's. All right, so now I've got 3.6.2, so we're going to get a point as an answer where this is your Y's. So 5.6, and this is going to be 4.8. So it's the same thing we did before. So point P is located at 4.8. So somewhere about right here would be point P. So it's the 3 steps. Find the distance, multiply it by the fraction, add it to the start. It's the same thing that we did before. Nothing changed. They just worded a little bit differently this time. All right, find the coordinates of point P along the directed line segment AB so that AP to PB is the given ratio. So now they give me this. So I'm going to have to use the distance formula or use slope or whatever. So what I'm going to do is use slope because it's easier than distance formula. So the slope is, so I've got x1, y1, x2, y2, and this is going to be our starting point here because it's telling me from A to B. So this is going to be my starting point. So the slope is going to be 4 minus 3 over 8 minus 1. So we get 1 over 7. Well, now that I've got 1 over 7, I'm going to multiply the top by the fraction. So how many parts are there? 4 plus 1 is 5 parts, and I'm going 4 parts in. So my fraction is 4/5. So we're going to multiply by 4/5 here and here. So now I've got 4/5 over 28/5. These are nasty. So 4/5 is the same thing as 0.8. 28/5 is 5.6. So I'm going to take my 0.8 and add it to the Y value of my start. And I'm going to take 5.6 and add it to the starting point of my X's. So this is 3.8 and this is 6.6. So that means point P is located at 6.6 and 3.8. So that means along this line segment, we're going to go 4 in. All right. So we'll practice some more on that. If we're going to identify parallel and perpendicular lines, so slopes of parallel lines have the same slope. So examples would be the slope of this one is 2. The slope of this one is 2. Therefore, these two lines are parallel. Since 2 equals 2, parallel. Check. The slope of this one is 1/2. Here I have to find the slope because they did not give it to me. So I'm going to subtract 3x from both sides. So I have negative 6y equals negative 3x plus 18. And then I'm going to divide every single piece by negative 6. So y is 1/2 x minus 3. And here the slope is 1/2. So these two lines are also parallel because they have the same slope. The slope of perpendicular lines is the opposite reciprocals. And if you multiply the slopes, you get the answer -1. So if you multiply your slopes. So what is the opposite reciprocal of 1 over 2? Flip it, 2 over 1, and change the sign. So if I multiply this, 1 over 2 times -2 over 1, I get -2 over 2, which is -1. Check. Perpendicular. The opposite of -4, well, if you'll put it over 1, it's easier to flip. So I flip it and it becomes 1 over 4. And since this one's negative, this one will be positive. Now multiply them. 4 over 1 times 1 over 4. You get -4 over 4, which is -1, perpendicular. Every time it's the same. All right, so let's finish up. So horizontal lines are parallel or perpendicular to the x-axis. So here's our x-axis. And horizontal lines, are they parallel or perpendicular? They are indeed parallel. So that means they have slope of 0. Vertical lines are parallel to the y-axis and have a slope that's undefined. So horizontal, so we got our horizontal lines, and vertical lines are straight up and down. All right, last part. Find the slope for the particular lines and determine if they're parallel, perpendicular, or neither. So I'm going to find the slope of this line. So you got your x1, y1, your x2, y2. So it's going to be 2 minus 0 over negative 2 minus 2. So 2 minus 0 is 2. Negative 2 minus 2 is negative 4, which is negative 1/2. And then we'll do this one. So same x1, y1, x2. So I'm going to go 4 minus negative 2, 4 minus 1. So this is 4 plus 2 is 6. 4 minus 1 is 3. 6 divided by 3 is 2. So if I multiply them, so these are going to be opposite reciprocals because I have a negative 1/2 and a positive 2 over 1, basically. So they are opposite and reciprocals. So the lines are perpendicular. So they are perpendicular. And because their slopes are opposite reciprocal, here, I'll type that so you guys can actually read it. So because their slopes are opposite reciprocals. And we'll make that workable there. All right, so let's do this last one, and we're on a grid this time, which makes life a little easier. So AB, so from A up to B. So I'm going to rise 2, 1, 2, 3, 4, and run 4. So rise 2, run 4, so that's 1/2. And then I'm going to do the same thing with CD. So 1, 2, 1, 2, 3, 4. So we're going to rise 2, run 4 again. So we're going to rise 2 and run 4. And these lines are parallel because they have the same slope. Let me make this. Oops, there we go. So because they have the same slope. All right, so that's all, and I will see you guys next time.